Which TEM grid should I choose? Lacey, Holey, or a Formvar carbon film? This is a fundamental question that often arises during sample preparation. In this video, we will address this topic to help you make the right selection. When working with suspensions or powder samples for transmission electron microscopy, TEM, the sample must be deposited onto a substrate and dried. This is typically done using a TEM grid, a small, delicate metal mesh, roughly 3 millimeters in diameter. These grids are commonly made of copper, nickel, or gold, and are often coated with a thin layer of carbon or Formvar to support fine specimens, such as nanoparticles or biological sections. Simply put, the TEM grid acts as the microscope slide for TEM, providing a stable platform for your specimen. There is a wide variety of grids available, each tailored for specific purposes. Let's break them down by material and application. Copper grids. These are the most common and cost-effective choice, ideal for general-purpose imaging. Nickel grids. These are essential when working with reagents or solutions that react with copper. They are also the preferred choice for most immunolabeling procedures. Gold grids. Gold is chemically inert and highly resistant to corrosion and oxidation. These are used in high-sensitivity analyses where even minor metallic contamination or reactions could compromise your results. While copper is the standard for most routine applications, the choice of the support film, the layer deposited onto the mesh, is equally critical. Support film types 1. Carbon-coated grids. Feature a thin layer of carbon to provide support for nanoparticles and delicate samples. 2. Holey carbon grids. Feature micron-scale holes. These are the gold standard for high-resolution imaging and Cryo-TEM. The uniform holes allow for imaging suspended areas without carbon interference, minimizing background noise. 3. Lacey carbon grids. Feature an irregular net-like structure. These are ideal for observing nanoparticles and 2D materials, as they provide various suspended areas without creating a distracting background. The Formvar grid. Another important type is the Formvar grid. These are coated with a thin polymer film that acts as a robust support for very thin or sparse samples. They are widely used for nanoparticles, viruses, and polymers that might otherwise fall through the holes of a standard grid. To enhance stability and conductivity, these are often reinforced with a thin layer of carbon, which combines the structural benefits of the polymer with the imaging quality of carbon. A note on costs. While prices vary by manufacturer and specifications, here is the general hierarchy, assuming a standard 3 mm, same mesh size grid, ordered from most budget-friendly to premium. 1. Copper grid, the most affordable and widely used. 2. Carbon-coated grid, slightly higher cost due to the added carbon layer. 3. Formvar-coated grid, more expensive due to the polymer coating process. 4. Lacey carbon grid, priced higher due to the complex manufacturing of the lace structure. 5. Holey carbon grid, typically more expensive than Lacey, especially specialized Cryo-TEM versions. 6. Nickel grid, slightly more expensive than copper. 7. Gold grid, the premium, most expensive option, reserved for specialized, high-precision applications. While other niche grids exist, these are the primary types you will encounter in the lab. Do you have any questions about selecting the right grid for your research? Drop a comment below.